Hi everyone. Today we are going to take another example to find the trigonometric ratios of an angle if a point on the terminal side of the angle is given. So we have a question where we have a point -4, 3. It's on the terminal side of an angle theta, and we have to find the 6 trigonometric functions of theta. So I'm going to start with drawing a graph, a rough graph. That's my x-axis, that's my y-axis. I'm going to mark -4 on the x-axis, and then I'm going to mark 3 on the y-axis, and the point will be somewhere here. I'm going to connect this point with the origin and then drop a perpendicular from the point to -4, and that's a right angle there. And this angle, the hypotenuse makes with the x-axis, is called theta. And now for clarity, I'm going to draw this triangle once again without the graph. So let's draw the triangle once again. This is -4, that was 3, and this angle is theta. We are going to look in the direction opposite to theta. That will be this. And I'm going to write a big O next to the 3. The leftover leg is the adjacent. Legs are the two perpendicular sides of the triangle, the right triangle. And the side opposite to the right angle is the hypotenuse. Now I'm going to use Pythagorean theorem to find the value of the hypotenuse. So hypotenuse is not known. I'm going to mark a question mark here, write a question mark. And I'm going to use the Pythagorean theorem, that's a squared plus b squared equals c squared. So for a, I'm going to write -4 squared plus 3 squared equals c squared. It does not matter. You can take any of the legs of the triangle as a and b. You'll still get the same result. So -4 squared is 16, 3 squared is 9 equals c squared, and 16 plus 9 is 25, 25 equals c squared. I'm going to take the square root of both the sides. Taking the square root of both the sides, the square and the square root gets cancelled, and the square root of 25 is 5. So 5 is equal to c, or c is equal to 5. So we found the hypotenuse. I'm going to label the triangle again. I'm going to write c, the hypotenuse is equal to 5. So let's go and write hypotenuse equals 5. Now that we have this right triangle, now it's going to be very easy. We are going to go and start finding the sine, cos, and tan. So let's start. So I'm going to write sine theta equals opposite over hypotenuse, that's equal to 3 over 5 cos theta. The formula is adjacent over hypotenuse. If you go and look here, what is adjacent? Adjacent is -4. Hypotenuse is 5. So let's go and write -4 over 5. And then comes tan theta. So let's see. First, I'm going to write tan theta. And tan theta is equal to opposite over adjacent. Let's look at the picture. Opposite is 3 here, and adjacent is -4. So it is going to be 3 over -4. And keep in mind, positive over negative is a negative. So that's going to be -3 over 4. And what I'm going to do here is I'm going to box all these that I found, the trig ratios. So this is -3 over 4. Then I had -4 over 5. And then I also had 3 over 5. So sine theta is 3 over 5, cos theta is -4 over 5, tan theta is -3 over 4. Next, I'm going to find the reciprocals. So reciprocal of sine theta. Let's do the reciprocal of sine theta. I'm going to start writing it next to it in a horizontal, try to write it in a horizontal line. So sine theta, the reciprocal of sine theta is cosecant theta, and cosecant theta is going to be hypotenuse over opposite, which is equal to 5 over 3. Again, I would like to box it just for clarity. And the reciprocal of cos theta is secant theta. So I'm going to write secant theta equals, let's flip. So hypotenuse over adjacent, flip the fraction, that's going to be 5 over -4. So we flip the fraction of cos theta, that's 5 over -4. And again, positive over negative is negative. So that's -5 over 4. And let's go and box it. So that's our secant theta. Now comes the reciprocal of tan theta, which is cotangent theta or cot theta. So I'm going to write cot theta. Let's take another color. So that's cot theta equals adjacent over opposite. So we are flipping the tan theta ratio. So that's going to be 4 over -3. And again, positive over negative is negative. So that's going to be -4 over 3. And let's go again and box it. So here we go. We have all the 6 trigonometric ratios of the function. And with this, we end our video. See you next time. Thank you.